So tension, inclines, and force systems. Okay, so first we have a triangle, and so the masses which I chose for this problem was 28, and the first mass is 28, the second mass is 26. The angle on the incline is 52 degrees, and we're going to solve for the inner triangle. So using geometry, we know that the angle on the inner triangle is going to be 38 degrees. Okay, so firstly we solve. We draw in a triangle actually, and then we know that this is going to be our F perpendicular and this is going to be our F parallel. And so we solve, then we check to know which side has a greater direction of motion. So whichever number is greater when we solve for Fg, which is practically mass times gravity, acceleration due to gravity, sorry, that gives us the direction of motion which you want to take. So if we have this, so we have 28 times 9.81 for instance, so we have 274.68 newtons, and then we have our F parallel. Because it's parallel, we have it as Fg parallel equals to 26 times 9.81 in brackets cos of 38 degrees, because this is going to be adjacent over hypotenuse, which is cos, and the angle in here is 38 degrees. So adjacent, which is the F parallel, and this is the cos due to SOHCAHTOA. And so moving on, we know that this is going to give us 200.99 newtons, and then we know that this is larger, and so now our coefficient of friction, which is one more thing which you have to account for in the question, is 0.12. So we have to acknowledge the presence of friction in the equation, and so we draw what forces act on the triangle. So we have here and here. So we have Fg, because it's pulling towards the ground, sorry. Then we have here to be tension, because it's opposing the motion. We also have here to be Fg, is pulling towards the earth. You can call it Fg2 to reduce confusion. And we have here as tension as well, which is opposing the motion. And because we know that this side is a direction of motion now, we can finally say that friction acts against it, which is friction this way, acting against this way. So now we calculate for our F friction, which is going to be mu. So now, because we know that friction is present, we want to calculate for friction. So the formula is mu Fn, which we can deduce to be mu F perpendicular due to this problem. And so we have it as 0.12, which is our coefficient of friction right from the start, and 26 because we're talking about perpendicular direction, so it's coming up as 26, and times 9.81, which is the force of gravity, acceleration due to gravity, sorry, then times sine of 38, because opposite over hypotenuse is sine, and our angle in the small triangle is 38 degrees, so we have it as 18.8437.